Just have a bit of quiet concentration for a moment. I'd just like to introduce Finn Christensen and David Ellison. These are kind of the experts in the additive manufacturing lab here, or rapid prototyping. So if you need any printing done, we can't do much at all, as Finn will tell you. But if you want a small amount produced up, these are the guys you have to speak to. And they're going to do a quick presentation for you now on what are the capabilities of additive manufacturing and some of the things you need to take into consideration. So thank you very much, Finn.
Thank you. Well, good morning, ladies and gentlemen. My name is Finn Påske Christensen. I'm a laboratory engineer in 427. My area of responsibility is day-to-day running of the 3D print lab and 2 other laboratories. In the late 60s, I was a skilled toolmaker. I was graduated as a production engineer, and my experience of field is manufacturing engineering since the mid-70s. The additive manufacturing, I have worked with this since 2006, approximately. I don't know what the topic, what you have called it until now, but I want to emphasize that we call it additive manufacturing. And that's why this organization, ASTM, American Society for Testing and Materials, has decided to call that it was adopted from this organization, and they decide to call it this, and this is the expression we will use in the future. Oh, the mic. I am not used to use this, so in fact, it's the first time I have spoken to in so large room. I normally teach in very small groups of 4 or 6 persons in Danish. So if you can't understand, or I can't understand your questions or hear it, you have to apologize. These expressions, as you can see here, you will see lots of other designations as the examples show here. But all these designations are technology based on the layered manufacturing. And to emphasize one more time that the additive manufacturing process builds parts by adding material layer by layer, as opposed to conventional manufacturing, which removes material and usually by machining. And regardless of the equipment, it's the same principle. A CAD model part is sliced into horizontally slices. And the slice in every cross-section is produced on the top of the former slice, normally. We have a machine which works in the opposite way, but that's another question. Additive manufacturing includes a lot of different processes and materials and equipment, and this equipment determines the process. In Department of Mechanical Engineering, we have 3 different types of machines and processes. And the first one, we call it a 3D printer, and it's really a 3D printer because this process is called 3D printing. The part material is plaster. Most of it can't work with sand, but we have only used it with plaster. The layer thickness is around 1/10 of a millimeter, and the working area is 200 times 250 times 200 millimeters maximum. The tolerances, I have mentioned that plus minus 0.5 millimeters. We have done it better, but I will prefer to keep these plus minus 0.5 millimeters. This machinery was relatively cheap to buy, around 150,000 Danish kroner in 2007, I guess. It's rather cheap to run. The material and other costs is 2 Danish crowns per cubic centimeter. And first of all, we are able to demonstrate the AM principle with that machinery. Unfortunately, the work pieces has limited strength and service life. Maybe you can, at least this is examples, very few examples, and maybe you can investigate them. The machinery looks like that. And in that box, we have 2 chambers, 2 areas. The left one is the material chamber, and the building chamber is here. The process is that a liquid adhesive is dosed on a thin layer of plaster. And it goes through the nozzles of a printhead installed in an XYZ system. And this glue is binding the particles together. Then another layer of plaster is deposited on the top of the first one, etc. And these layers are self-supporting. If you can see, we go back one. Here you have a detail which, if it was a liquid material, you couldn't do it. But here you have some plaster. Hvor fik jeg skulle lave det derinde? Hvad skete der nu? Here. Here you see the plaster with no liquid is supporting this detail. After the model is finished, in our machinery, you have to keep the model in the machinery for 1 hour, just to let all the moisture out. The temperature in the machinery is around 38 degrees centigrade, and some of this moisture will evaporate at that time. If you remove it before this 1 hour, the part will break. After that, you have to bake it in an oven at around 80 to 90 degrees. And then the part is, as some of the parts is circulating here. But you can reinforce the part with infiltration, with varnish or super glue, and it's really good. Of course, there's a lot of other processes are using, for instance, laser light, producing work pieces of polymer and metal, but that's all for our machine, one of them. Some examples, and if you go through building 427 in, well, just before the yard, you will see some of these examples, these figures from, what is the name of the game?
It's called Spore.
Spore figures, yes. We also have these kinds of examples, but you can see for yourself. As you can see, you can make some things that you can't make in any other way. If you didn't use this additive manufacturing, because you can see this, oh, well, it's not very good. But this chain is free, but it is fixed in this cage. The next machine has a very large name, the per factory, meaning multi-lens system, and the company is called Envisiontec, and it looks like that. You have to hide the working area behind this shield because it's worked with liquid plastic which cure with visible light. So, and here you see the hood is raised. Well, I didn't expect so much light here, but it's very hard to see. Yeah, that's quite better. Here on my screen is very nice picture. Yeah, it's very hard to see, but here up you have a build plate and it is immersed down in this basement with liquid photopolymer. And from the bottom, you can't, in here you have a big system with lenses, and the light goes from bottom and through the plate, as you saw, through this plate, and then the model is cured from the bottom. And then you can make parts of, the maximum is 84 times 63 times 230. That's the maximum, so it's very small. The layer thickness is from 15 to around 50 microns, and the tolerances is plus minus 20 microns. And that's the advantages with this machinery. It's expensive to buy, more than 500,000 Danish kroner. Expensive to run. The material costs around 3,000 kroner per kilo, and the process is comparatively slow. These kinds made in this way took around 8 or 9 hours. But yeah, and the post-processing is rather complicated. You had to work with IPA and some other equipment, which it takes very long time. But we are able to produce very small details, and that means the features down to around 50 microns XYZ. And that's why we bought it. And here you see an example. Well, now I know I forgot this. I have some models like these for the years, and every manufacturing of hearing aid in the world, they use this method to make the shells, as you see here. You start with a imprint of silicone of the ear, then you scan it, then you can make your files for the process. Then you have our per factory machinery, and the post-processing for the surface and the final shell, install the equipment, and here you can see you can make 8, 16, 38, up to a couple of hundred of these shells in the same process. So that's really an advantage. And here you see the finished parts. Well, that's all for my talk. So have you any questions? Yes?
If we have a product that we would like to have a prototype made of, is that possible?
It depends.
It's small.
A very small one, and should it be in plastics or in?
Doesn't really matter. Just we need the functional outline of it.
Well, as maybe you can understand that our plaster models can be used for limited function models, and the plastic models is better for that. But we will prefer to make the models in plaster because it's much easier process and much faster. So, and there are some constraints that if you have an assembly, you have to make it in one part, otherwise it fall ahead. I always said that let's see the file and look at it, and maybe sometimes we can downscale it if it's too big. Many times it's too big to our machinery, but we can downscale it if it's okay. But let's look at it.
What is the process of engagement for the students? Should they email you a part file?
It would be a good idea. If I email another constraint, it has to be an STL file. STL.
So,
and that's...
You can save all your CAD files as STL files. You can either export it or do save as, and there's a format called STL.
Yeah.
So if you just send that version. And then perhaps a description of what the prototype is for.
Yeah, it would be nice, yes. And then I could answer, yeah.
Would it be okay if I just put in your contact details?
Yeah, of course. Okay. So, that's all of that.
I'm getting some other machines, maybe we can do moving parts.
I'm sorry.
I'm planning on getting some new machines who will do moving parts or coloring or anything.
Do you ask if we are getting some new machines?
Are you planning?
We would love to have some new machines. And we are working on getting machines which can make parts in metal. But until now, it's a dream. Yeah.
It's on the internet. You can find plans for making 3D printers using components from old printers and things like that you can access. I mean, did you make this yourselves in house?
Well, that's David's talk. So maybe he will take over.
But you can, I think it's fair to say that you can produce some parts and then have them interface with other components. You don't have to rule out the mechanisms completely. These types of printers work with mechanisms. You can get the parts to engage with each other, also engage with metal or physical parts. Just because your device has a mechanism doesn't mean you can't use rapid prototyping for some elements of it. Is that fair to say?
Yeah.
Well, thank you very much, Finn. Thank you for your talk.
You're welcome.
So now, I think we're passing over to David Pedersen, who's I've just come into contact with in the last 6 months and realised he's a bit of a genius when it comes to rapid prototyping. He seems to make all these things himself. The ones that are available on the internet don't work half as well as the one he's built himself. So he's really a man in the know in this respect. So,
thank you. So, to do something a bit different, I won't bother you with a PowerPoint. Instead, I will take you on a little tour on the internet, talk about what's going on in the different communities working with additive manufacturing processes, and show you guys what you can do if you feel that our facilities at the university is not good enough. First of all, let's assume you have a brilliant idea. You want to make your own design of, let's say, a phone cover for an iPhone. We should be able to produce that for less than a few hundred Danish kroner to be able to sell it for anybody to like our product. And of course, it should be something that we can realize in an easy manner and get out to customers, preferably worldwide. Traditionally, that would mean that you needed to set up a production facility. You needed to start advertising for your products in order to get a customer base. And there would probably be several years before you would start seeing any kind of turnover. I would like to show you guys how you can be your own product designer, product developer overnight. All you need is basically to go home, start up your CAD software, and start designing. And how can that be? Well, that's thanks to a company called Shapeways. Shapeways is what we call a print shop. Traditionally, print shops has only been supporting the industry, making prototypes for big companies. But what Shapeways is a company that now offers 3D printing for the masses. So everybody who can produce a CAD file can get it printed. And I'm sorry that I'm abusing the word printing because it's called additive manufacturing, but it's a bad habit of mine. But what you can do here is to upload your CAD file and then get it printed for almost nothing. And this is a print shop with a twist. It also functions as a bit like an app store for smartphones. So as soon as you've been uploading your CAD file, it's automatically for sale on the Shapeways web shop. And when visitors come there, see your smart design and fancy it and want to buy it, then of course you earn royalties from the sale. So you split the profit with the Shapeways company. A bit like when you decide to make your own iPhone application and put it on the App Store, then every time a sale is generated, you share the profit with Apple. So see if we can find, for example, an iPhone cover. I'm looking for one specific one that I'm normally using when I'm showing off this website. So if you can bear with me for a moment. Oh well, let's just pick a random one. Here, it's a quite boring design, but here there's a designer who has been uploading his CAD model, and as soon as he has uploaded the CAD model, it's automatically for sale. You can choose whatever material you want it to be made in. You can have it gold-plated if you want to make it fancy. You can also go with a plate, white polymer color. And then you can see the cost price of this cover is actually somewhat less than you would expect to pay downtown if you went to a store. And as I said, every time somebody goes in here, finds something they like, and buy it, the designer who made this thing earns a little profit. Of course, there's also jewelry. Some of them are quite intricate and detailed. And it's really amazing that you, for a price that is often less than in the jewelry store, can get your things made in a variety of noble metals such as silver, titanium, and so forth. So this is a place for you to go if you want to use additive manufacturing technologies in your designs. You want it fast, you want it printed professionally, and you want it cheap. And of course, if you want to start up your own business, this is a quite clever way of doing it. Now, what if, yeah?
You are committed to share your idea.
You are not automatically committed to share your idea. You can make a design, upload it, and say, this is for me only. And then they will print it only for you, and it will not become available in the store. Now, what if this is all right, but you're sitting there and thinking, why can't I have a printer back home like my paper printer? Why can't I have a 3D printer? Well, of course you can. You can have a machine like the one running over here. Building a little polymer-based additive manufacturing system costs less than 1,000 euros. And the parts that we can make on such a machine is quite rough. But nonetheless, for prototyping or for making spare parts for your home, if you have lost the battery cover for your TV remote or whatever, these small machines work quite brilliant. Most of them are based upon an open source project that is called RepRap. RepRap is an abbreviation of two words, which is self-replicating rapid prototyping machines. And basically you can go to reprap.org, and there you can find all the documentation for building a machine yourself. There's all the electronic designs, all the hardware design, all the software you need to get up running. If you choose reprap.org as your entry point to this home printing technology, you are really starting up a hobby. You don't get a machine that is running. You need to, first of all, build it yourself. After you've spent weeks, if not months, building your own machine, you need to learn how to run it. And that is a quite steep learning curve. It takes quite a while to figure out how to actually get the machine to print anything. So if you like DIY projects, like mingling about with tools on the kitchen table, this is the way to go. If you want a home printer for less than 1,000 euros, or roughly 1,000 euros, and you don't want to bother about figuring out how to build it, how to get it up running, you can also buy these small machines or commercial derivatives of this platform as a kit, a bit like when you buy an IKEA furniture. You will get a big flat package. Inside it you will find an Allen wrench, and you will start assembling it following simple assembly instructions. So if we go to one of the popular machines, it's called the Ultimaker. Here we go. Then you will be able to buy a machine that is made out of plywood. That takes roughly a week to assemble, and then you're up running. You will probably be able to see some resemblance between the machine running down here and the Ultimaker. It's a Cartesian robot. We have a nozzle moving in X, Y, and the Z direction that is extruding a polymer as a thin thread, and then basically we are weaving up our parts. It uses a 3mm filament on a spool. It costs roughly 500 Danish kroner for a spool, and it lasts pretty much forever. Some of these small hobby machines can print in different colors. They have multiple print heads threaded with different filaments in different colors. So you can make 2 or 3 of 10 color parts as you're printing. And especially this Ultimaker platform is a no-nonsense platform. It's a matter of assembling it, and then it's just as easy to start up as a paper printer. So that's a bit about how you can get started with these technologies if you are not, if you don't want to directly involve DTU. You can either go for the Shapeways method, which is a complete no-nonsense method. You don't have to think about what you're doing, just produce the CAD file and pay a small fee. Or you can find yourself a new hobby, get your own machine back home, and start printing all sorts of wonderful stuff. If you want inspiration for what to print, there's another awesome website called Thingiverse. Thingiverse is a place to share designs. And the idea is basically, if you have made something you like and you want to share with the hobby community, you will just upload your CAD file. There's some featured parts on the front page you can browse through and see. and print for yourself. And they sort the different designs in different categories, such as, for example, popular. You can see you can, for example, here, print and build your own robot for printing eggs. So if you want to make fancy Easter eggs, you can build your own robot to do that automatically for you. And here, all the yellow parts are available on Thingiverse. You can just download the CAD files, press print on your home system, and then in a matter of a day or two, you will have your own egg printing robot, just to take a silly example. There's actually quite a big community out there getting all sorts of crazy ideas. And what I really like about these technologies is that when you first have a machine available, you really start producing some of your wonderful designs. If you don't have any manufacturing technologies readily available, all the ideas stays in your head and they are not really getting manifested in any way. But as soon as you have your own 3D printer or know somebody at the dorm having one, or knowing a nerd like me who actually spends his professional career playing with these machines, then you can realize your wonderful designs in a matter of hours. That's really where this technology wows people. That's when you go from CAD model to a physical part in a matter of 1 or 2 hours. Aside from that, we've got a machine up here running. If any of you want a closer look, I suggest that you get off your chairs and go down here and see what's happening. Right now we are printing a tentacle, because you can never have too many tentacles. Get a feel of what's going on. And of course, if there's any questions, feel free to fire at will. No questions?
I have a question. How is the possibility for the students to get something printed on?
Yeah, the possibilities for getting something printed on this machine is not as big as using the plaster of Paris machine. Basically because our machine, or the plaster of Paris machine is a commercial machine. You basically start it up as easy as starting a paper printer and everything just runs. You don't have to think about your design. Whatever you make can be printed. On this machine, first of all, there's some limitation to what is possible. And you really need to spend some time looking at the CAD model in order to ensure that it will print correctly. Furthermore, this is an experimental platform. It's not really running stable. So chances are that if you come and say, I would like to have this printed in plastic, then I might have half or fully disassembled it because I'm doing some fancy upgrades on the machine. So getting your own designs realized on this platform in our facility is not something that you can rely on. But then again, if you want a part in polymer or in metal, go to Shapeways, spend 10, 20 euros to get it realized, and you will have something that is very good.
What kind of machines are Shapeways using, like, to make these high quality products?
Shapeways are using selective laser sintering. It's basically working like our plaster printer. So we spread out a thin layer of powder, and then they bump the powder using a laser beam. Then they have SLA machines, selective laser activation, where you have a photomonomer that you cure by exposing it to UV light. Basically, as far as I know, they have all the commercially available technologies in-house. And then, of course, when you buy something from them, then you have to specify which material and thereby also which process you want to use.
So should we take 5 minutes to bring all the models down to the front and come have a look at the device if you'd like to? Yeah,